In this lab, we will use the three learning methods for the tree-based model, classification tree, random forest and gradient boosting method. We will choose precision for performance measure and find the best classifier. We will use the data from the previous lab, mobile underscore train and mobile underscore test. First, we assign the train independent and dependent variables and the test independent and dependent variables. So let x underscore train equal mobile underscore train dot drop price range comma x is equal 1. So x underscore train will be all the independent variables except price range, and let y underscore train equal mobile underscore train of price range. And the test data, let x underscore test equal mobile underscore test dot drop price range comma x is equal 1, and let y underscore test equal mobile underscore test of price range. Import numpy is np from sklearn dot model underscore selection import grid search cv. Define hyperparameter grid for tuning. Consider complexity related parameters. Let param underscore grid equal Kelly braces. So this will be in a dictionary form. Max underscore depth is 3, 5, and 7. Min underscore samples underscore split is 2, 5, 10. Min underscore samples underscore leaf is 1, 2, 4. CCP underscore alpha is np dot I range from 0 to 1 with a distance of 0.01. This is the cost complexity pruning consider range. So param grade is printed to be like this. For CCP underscore alpha, it's an array from for 0, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06 till 0.07, 0.08, and 0.09. From sklearn.tree, import decision tree classifier. Create decision tree classifier and perform grid search. Let model equal decision tree classifier, open and close bracket. Let grid underscore search equal grid search CV, open bracket, model, comma, param underscore grid, comma, scoring equal accuracy, comma, CV equal 5. Grid search dot fit X train and Y train. Now, so the best estimator is, so to get the best estimator, best model, we let mobile underscore tree equal grid underscore search dot best underscore estimator underscore index decision tree with maximum depth equal 7. Decision tree classifier with maximum underscore depth equals 7. Min underscore samples underscore leaf equal 4. Min underscore samples underscore split equal 10. Now if I do mobile tree dot predict of x test, it prints all these values. Now from sklearn.matrix, we import confusion matrix. Confusion underscore matrix of y underscore prediction, comma y underscore test. This is just showing the working. So we can see that in the diagonal, there is 244, 230, 218, 199. And the values are of the diagonal values are 17, 0, 0, 25, 0, 26, 14.0.19.0.0.8. Precision function, definition, precision of y underscore pred, comma, train dependent values. Mx equal confusion underscore matrix of predicted values and the test values. Let z equal 0 for I in range length of ytest.unique. Now ytest.unique will be printing the levels, which is 0, 1, 2, 3. To show you, insert a new row, ytest unique. Text 0, 1, 2, 3. And the length is 4. So for I in the range 4, that is from 0, 1, 2, 3, let z equal z plus confusion matrix of I, row I, column I, so that is the diagonal values, divided by sum of confusion matrix that particular row. So that will be the first value will be 244 divided by 261, and then it will be added to 230 divided by 269, and so on, and then retain z on I. So I will be uh, 3, yeah, 0, 1, 2, 3, and z is divided by 3. So okay, so here, so if we are calculating tree underscore p equal precision of mobile tree dot predict of x test and y test, then it calls the precision function, which is this one, and it does, we will insert a new row, new cell, and let's do that. So first value will be 244 divided by 261 plus 230 divided by 269 plus 218 divided by 263 plus 199 divided by 207, and that gives 3.58 and so on. Now if I divide that by 3, then that's 1.19 and so on. So some, yeah, so 20, 37, 63, 63. Yeah, so but mobile 3 is this one. Let's find out what's the value of I. Let's print I. We need to print here. So print I. Let's run that. And then run this. So I is 3. Okay, so looks like print mx. Let's remove print I. It has changed. So we need to put a random seed. Yes, we need to put a random seed. So because it's changing. So um, let's let's import random and run that, and let's set random seed equal 1 2 3. Let's run this. Okay, now if I run this again, it will give the same value. So yeah, so that's correct. From sklearn dot ensemble import random forest classifier. So define hyperparameter grid for tuning, that is consider complexity related parameters. Param grid and underscore estimators is 100 and 150. Let max underscore depth equal 357. Let min underscore samples underscore split equal 2510. Let min underscore samples underscore leaf equal 124. Let max underscore features equal square root n log 2 and none. Create a random forest classifier and perform grid search. Model equal random forest classifier, open and close bracket. Grid search equal grid search CV, open bracket, model, comma, grade, that is parameter grade, comma, scoring equal accuracy, comma, CV, text cross validation equal 5. So it does the cross validation 5 times. Grid underscore search dot fit x underscore train y underscore train. So it gives this. Now let's look at the best model. Get best model and predictions. Let mobile underscore rf equal grid underscore search dot best underscore estimator underscore and printing mobile underscore rf text random forest classifier with maximum underscore max underscore depth equals 7, max underscore features equal none, min underscore samples underscore leaf equal 2, min underscore samples underscore split equal 10, n underscore estimators equal 150. Show working. Mobile underscore rf dot predict x underscore test gives this. Random forest. Let rf underscore p equal precision of mobile underscore rf dot predict x underscore test. So that is the predicted y value and the test value, and that prints 1.187 and so on. From sklearn.ensemble, import gradient boosting classifier, define hyperparameter grid for tuning, consider complexity related parameters, let param underscore grid equal curly braces, and at underscore estimators is 500 and 2000, max underscore depth is 3 and 7, min underscore samples underscore leaf is 2 and 4, learning underscore rate is 0.01, 0.1. Create a gradient boosting classifier and perform grid search. Let model equal gradient boosting classifier open and close bracket. Let grid search equal grid search CV of model param underscore grade, scoring equal accuracy, cross validation equal to. I'm selecting cross validation equal 2 because if a cross validation equal 5, then it takes very long time. Grid underscore search dot fit x underscore train y underscore train, and get best model and prediction. Let mobile underscore GB equal grid underscore search dot best underscore estimator underscore printing mobile underscore GB that gives gradient boosting classifier of min underscore samples underscore leaf equal 4 and n underscore estimators equal 500. Mobile underscore GB fit x underscore train y underscore train. So that's again the gradient boosting classifier. We have already fitted x train and y train, so why this again? So show working here. So predict x test, the test get the covariate values for the x that the mobile test data, and that gives this. Now get training loss. Let training loss equal mobile underscore GB dot train underscore score underscore, and the training loss values are printed here. Let's plot the training loss data. Import matplotlib.pyplot has PLT. Plot training loss. PLT.plot of training underscore loss, label equal training loss. And so this label is in the legend here, as you can see, because we have written here plt.legend open and close bracket. plt.x label is boosting iterations, and plt the y label is deviance, and the title is gradient boosting training deviance. And we can see that the deviance, it decreases as the number of boosting iterations increases. Then from sklearn.matrix we import mean underscore squared underscore error, and then we have already imported the random. We have to set random dot seed, which is 1 2 3, and mobile underscore gradient boosting dot predict the test independent values, and these are this. And show working for I and Y prediction in enumerate, mobile underscore GB dot staged underscore predict of the test covariate values, and print the predicted Y values, and that gives this. Show working np dot zeros of mobile underscore GB dot n underscore estimators, bracket, d tab data type equal np.int64, it prints the 500 values of 0. Find the mean squared error of test and predictions. Let test underscore score equal np.zeros of mobile underscore gb dot n underscore estimators. Data type is np.float64. Random.seed is 123. For I, y prediction in enumerate the mobile gb.staged underscore predict of x underscore test. Let test underscore score of at that position I equal mean underscore squared underscore error of y test and y prediction. And when we print the test score, it prints this. So here in this set of commands, we will plot a training and test set deviance. So let figure equal plt.figure fixed size equals 6,6. But let plt.subplot is 111. Plt.title is deviance. Plt.plot open bracket np.irange mobile underscore gb dot n underscore estimators +1, comma mobile underscore gb dot train underscore score underscore comma b dash label equal training set deviance plt.plot open bracket np.irange of mobile underscore gb dot n underscore estimators, that will be 0 from to 500 +1 test score. So the test score that we found over here, these values, comma r dash comma label equal test set deviance plt.legend location equal upper right plt.x label boosting iterations and plt.y label deviance and fig.tight underscore layout open and close bracket plt show. So that gives this. And if we don't do tight layout, it prints this. And if we do the tight layout, then it prints this. Price range probabilities are computed. Mobile underscore gb dot predict of x test, and it prints this. Gradient boosting method. So we call the precision. Let gb underscore p equal precision of mobile underscore gb dot predict of x test comma y test, and it prints this. Now if I form the array of the precision values for decision tree, random forest and gradient boosting, so we see that gradient boosting method yields the highest precision and is the best classifier.